This is part 3 of logarithms. We're going to go over how to graph logarithmic functions. So here's the question. How would we graph f of x equals the log of x base 2? That looks kind of tricky. Well, the first thing we could do is rewrite this f of x as y equals the log of x base 2, and then we can rewrite that as an exponential function. So remember what we do? We take the base 2 and we raise it to the other number. That's the exponent over here, right? So we have 2 to the y equals x. Now, you could write equals x, or you could write x equals 2 to the y. I think that's easier for most people to see it written this way, x equals 2 to the y. But of course, 2 to the y equals x is exactly the same equation. So the question is, how are we going to graph x equals 2 to the y? Well, we could make a table of ordered pairs. But it would make sense to put in something for x. It'd be easier to put a number in for the exponent, and then we'll be able to do 2 to that exponent and figure out what x is. So we're going to put in numbers for y first, and the exponent can be any number. So let's put in, let's say, -2, -1, 0, 1, and 2. And we know that x is 2 to the y. So 2 to the y would mean 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, 2 squared. I'm just plugging in that value of y, and then I'm going to simplify it. 2 to the -2 is 1 over 2 squared, which is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1, 2, and 4. Now here's where you have to be careful. Notice this is your x column, and over here the first one was your y column, so if you want to see the ordered pairs written correctly, it's 1/4 -2 is the ordered pair. And 1/2 -1 is the ordered pair. And 1, 0, 2, 1, and 2, 4. So when we graph, we've got to make sure we do the ordered pairs correctly. Now the interesting thing is this is the inverse function of y equals 2 to the x, which we graphed when we were doing exponential functions, and all of these ordered pairs are simply reversed. So another way to do this is, if you're trying to do x equals 2 to the y, you could just take, if you've already done it, y equals 2 to the x and switch all the ordered pairs. You'll get exactly the same thing. But these are the correct ordered pairs to graph y equals log of x base 2. So now we need to, as accurately as possible, graph these. Hey, I just found a mistake. Notice I did this last ordered pair incorrectly. Anyone else catch that? So that's 4, 2. That's the correct one to do. Okay, so I'm going to write these 5 ordered pairs and then do it on a graph. So put the video on pause and try it and see if you get a picture of what your graph looks like. Okay, here were the 5 ordered pairs. This is the graph, so we kind of get a picture of what's going on here. And remember, this was x equals 2 to the y, or y equals log base 2 of x was the original. All right, so in red, and what I said, that was the inverse of the function y equals 2 to the x, which, of course, if you just get all the ordered pairs, you take all the ordered pairs and switch them, you should get the graph of y equals 2 to the x. So let's just do that. If I switch the ordered pairs, I'd have -2, 1/4. So I'd have -2 up 1/4. I'd have -1, 1/2. I'd have 0, 1. I'd have 1, 2. And 2, 4. So anytime you're doing inverses, that's another way of getting it. You would just switch all the x and y order pairs. So this is y equals 2 to the x, and then in red is its inverse function, y equals log of x base 2. And so that's how you could graph any log function. All right? You can simply graph the exponential function, change it to exponential, plug in values for y, figure out what x is, or you could actually do the exponential function like y equals 2 to the x and then switch all the ordered pairs to get it. Whatever's easiest for you. Anytime you need to graph an exponential or a logarithmic function, you could certainly plug in values for x or y and find out several ordered pairs and get a picture of it. But it's nice to have a basic idea of what an exponential function looks like, the graph of an exponential function, and the graph of a logarithmic function. So again, the purple one is the exponential function. Notice it goes through 0, 1, because when you put in 0 for x, any positive number to the 0 power is going to be 1. So that's why 0, 1 is on this. If we look at the other graph of the logarithmic function, we have, that's the same thing as x equals 2 to the y. So when you put in 0 for y, you'll get 1 for x, and that's why 1, 0 is on this function. So let's analyze these two. The basic exponential function here, y equals b to the x, looks something like this. Notice to the left it gets really close to the x-axis, but it doesn't go below it because the y value will never be negative if b is positive. And it goes up forever. It also goes to the right forever. X could be anything. If we look at the basic logarithmic function here, we see it goes through 1, 0, right? And it leads this way. The whole graph is to the right of the y-axis. Now what you have to be careful on both of these is, this is just the basic one. If I have a minus sign in front of the b, the whole thing is going to be like flipped below the x-axis, right? Because all the y values would be flipped. Or if I had something like for the exponent x minus 3, or if I had b to the x plus 9, everything would be up higher. It wouldn't go through 0, 1, etc. Same thing for the logarithmic function. But we're just getting a basic idea of the difference between these two functions, what they look like. It'll be useful when you're graphing. But of course, you can always make up a set of ordered pairs and go ahead and graph it. So next time somebody says y equals log base 3 of x, you could think, well, I know that log function looks something like this, okay? And you have a basic idea of what it's going to look like, and you know it's going to go through 1, 0, okay? Or what you could do is write this in exponential form, 3 to the y equals x, and I'm going to write that as x equals 3 to the y, and then just go ahead and plot some points. But the tricky part is, remember, you want to put in values for y and then figure out what x is going to be. Okay? So in any case, when all is said and done, you'll be able to get the correct graph from these set of ordered pairs, but it should look similar to this basic look. Okay, and it's just a matter of practice, plugging in the values, remembering how to write a logarithmic equation as an exponential equation.